All right, this video is going to take us through 10.2, which talks about exponent rules and how exponents and radicals are related. So one of the first rules we're going to look at is the product rule, where if you multiply two things with the same base, you can add the exponents to get the same answer. For example, here, 2 to the third and 2 to the seventh have the same base. It's 2. So we can add those exponents and we'd end up with the same answer. Well, 3 plus 7 is 10. Let's check a calculator and see how that works. So 2 to the third times 2 to the seventh gives us 1024. 2 to the 10th gives us 1024. So that just shows you that it does work. Don't do anything with the bases, just keep them the same. Works the same thing with variables. So if we have an x and an x, we can add our 2 and our 7, our 2 and our 5, and get 7. Same thing works with fractions. 1/2 plus 1/2 is 2 halves, which is the same as 1 whole, which is just the same as x. All right, exponents and radicals go back and forth. Sorry, having a moment. That exponent, if it's rational or a fraction, can turn into a radical. The denominator becomes the index. The numerator is an exponent. And it doesn't matter if the exponent is on the inside or the outside of the radical. For example here, 7 is our base, so it stays in the radical. 5 is the denominator, so it goes here as our index. And the 1 is our exponent. Now you don't typically have to write 1, so it doesn't matter. Both of those would be correct. Here, we're going to put 8 as our base. The denominator goes there, and 2, the radical goes right over there. So that's how you can rewrite it. And again, it doesn't matter if you have it on the inside or the outside of the radical, they get the same value. All right, this one, write each expression in radical notation, then evaluate. So let's look at this one. 36 would be our base. Denominator here, exponents 1. The next one, 23 is our base. Denominator here, exponents 1. Last one, x is our base. Denominator's 3, exponents 1. Now, if I were to do this, the square root of 36 is 6. The square root of 23, I don't know. So let's look at it in our calculator. Before, when we had the cubed under math, now if we go down to number 5, it will bring you a little thing. So math 5 will bring you so that you can type in the index and then type your 23. Now we can round to the nearest hundredth. So again, that's the math button, which is right under alpha, and then 5 will let you put your own in. All right, let's look at the next one. Our denominator is 2. Our base is 5x, exponents 1. Next one, denominator is negative 27. Our base is negative 27. The denominator is 3. Exponent is 2. That one I can type right in the calculator if you don't know it. So math 5, I make that a 3. In here I put negative 27. Then I'm going to arrow over and do caret 2. And I get 9. Now let's look at that by hand. One way to do it is to say, hey, the cubed root of negative 27 is negative 3. And negative 3 squared is 9. That's one method. The other one is to square it first. So negative 27 squared is 729. And then the cubed root of 729, math for 729, is also 9. So there's 2 different ways to get that, well, 3, I guess, if you use the calculator. All right, so you should pause the video and try this last one, see how you do. All right, our radical notation would be root 5, 12 to the third. And then in my calculator, I could type one of 2 ways. I could do 5 here, 12, go outside and do caret 3. Or I could do the same thing, but leave the 3 inside. It's just another way to show you both ways get you the same answer, whether the 3 is inside or outside of your radical. The next exponent rule we're going to think about are negative exponents. A negative exponent takes whatever it is and brings it to the bottom of the fraction. For example, a to the negative fifth is the same as saying 1 over a to the fifth. A to the negative 2/3 is the same as saying 1 over a to the positive 2/3. It just puts it on the bottom of a fraction. If it's on the bottom, moves it to the top. So let's look at some examples. We're going to write in radical notation, then we're going to evaluate. So this negative tells us we're going on the bottom. Then we put it in radical notation, and then we evaluate. So if you know what the cubed root of 64 is, go ahead and do it. If not, I'm just going to type 1 divided by math 5, put a little 3 here, and then put 64 squared inside, and I get 0.0625. Would help if I wrote the whole thing, 0.625. Now, if I wanted that as a fraction, I don't know if you remember, but you hit the math button and then enter, and that'll turn it into a fraction, 1/16. All right, so you try this one. Negative sign means it goes underneath. 4 goes there, 81 cubed. So 1 divided by 4th root of 81 cubed, and I get 0.037, but as a fraction, that's 1 over 27. Either of those is fine. All right, so this also works the other way. If we can take a fraction exponent and turn it into a radical, we can take a radical and turn it into a fraction exponent. So the base, the big number becomes our base. The numerator is the exponent. The denominator is the index. Same thing here. B would be our base. If there's no number, that's a square root because that's what we typically use. So this fraction would be 5 over 2. And the fact that it's on the bottom of a fraction there would make the exponent negative. Don't let answers scare you. This is in parentheses, so this is our base. Keep it in parentheses. Then we just do our fraction, 2 over 3. This one's not in parentheses, but we can put it in parentheses. 3 is our denominator. There's no fraction, no exponent here, so we put 1. I put 1 and not the 2 because exponents don't distribute when you're adding. So this is really our base, and the exponent is a 1 out there. So be careful of that. Now, quick review. These are all the exponent rules you've learned at some point in your life. Whether you remember them or not, that's your call. But they'll be on your note sheet. You just have to understand what they mean. So here, product rule, P, same base, we're multiplying, so we add the exponents. If that's the case, when we're dividing, what do you think we do? We subtract the exponents. That's not the right division one. That's this one here, where we have the same base and we're dividing. P minus Q. All right, another one, negative. We talked about that. It just brings whatever it is to the bottom. If you have a negative and it's already a fraction, what it's really going to do is it's going to bring that top number to the bottom and the bottom number to the top. So it's going to flip the fraction, and then you have your exponent. When you're multiplying and dividing, your exponent distributes. So it's like saying a to the p, b to the p. And here would be the same thing with the b's on top. Now on those two that I just did, where it's red, this one and this one, we can't subtract the exponents because the a and the b are different. If they're the same number, you can subtract them. But if the a and the b are different numbers, you can't. You leave it like that. Here we're going to multiply, so it'd be p times q. And again, this last one we distribute a, b. We can't add them because they're different numbers. So those rules will be on your sheet, but you have to understand how to use them. All right, let's look at combining those things. So here we have square root of x times cubed root of x. Now they have different indexes, so we can't just combine them. Instead, I'm going to turn them into exponential form. So this would be x to the 1/2. This would be x to the 1/3. When things are multiplied together, we can add them. So we can rewrite this as saying 1/2 plus 1/3. Now to add fractions, we need common denominators. So we can get those to 6. If I multiply this by 3, we get 3 6. Multiply this by 2, I get 2 6. And 3 plus 2 is 5. And we have a positive exponent, so we can stop there, x to the 5/6. All right, let's try this one. We're going to break this into the number and the variable, which we can do because we're multiplying. The cubed root of 27 is 3. And then if I rewrite this x, now we have a positive exponent of 2/3. And those are multiplied together. No big deal. Let's do the same thing here. We're going to break that 16 and the x. The 4th root of 16. Now, I did this table before. So 4th root of 16 gives us 2. So that's going to turn, let me try to move this table. There we go. That's going to turn that top part into a 2. Then the 4th root of x can be written as x to the 1/4. And the cubed root can be written as x to the 1/3. Division means we can subtract our exponents. So we're saying 1/4 minus 1/3. To do that, we'd multiply this by 3. So we would get 3 over 12. Multiply this by 4. We would get 4 over 12. 3 minus 4 is negative 1/12. Now that negative is going to bring it to the bottom of the fraction because the direction said only positive exponents. Notice the 2 doesn't move because that exponent is 1. So that has a positive exponent. It's going to stay right where it is. All right, let's try. I'm going to move that actually. Look at that. Okay, let's try the next one. All right, here we have a negative exponent and a fraction. So it's going to flip our fraction. Let's start with that. Now we have 1/2. Then we're going to distribute this. So we have 81 to the 1/2 and 1/2 times 2. Well, half of 2 is 1. And if we rewrote the 81 to the 1/2, square root of 81 is 9. And the x stays on the bottom because it's positive. So those are some ways to go back and forth and simplify. Let's keep going with this. Okay, this first one right here is a square root. So it's like saying x plus 1 to the 1/2. And then we leave it in the cubed root. Now we're going to take that cubed root and rewrite it as 1/3. And when you have power to power, you can multiply. So 1 times 1 is 1. 2 times 3 is 6. And that's as far as I can go. This one here, we would rewrite as 15 over 5. And 15 divided by 5 is 3. So we've simplified that. This next one, we have a negative exponent on the y. So that's going to bring that to the bottom. And then we have a negative exponent on the x. So that's going to bring that to the top. And now we have our positive exponents. When we're multiplying, we can distribute. So root x is the same as x to the 1/2. So x to the 1/2 times x to the 1/2 is like saying 1/2 plus 1/2, which is 1 whole. And then I would distribute this. So we get minus x to the 1/2. Because anything times 1 is itself 1/2. So there's that. So that was a really quick review of the exponent rules. If you need help or more practice, let me know. And that's the end of 10-2.